I'm Patty Simpson with Simpson Math. Let's find the mean absolute deviation for an example problem. So first, remember that the mean absolute deviation is just the average distance that our data values are from the mean. And we have the formula here for MAD, and while the notation is different, depending on if we have a population data, if we collect a census, or if we have a sample data, just data from the sample, our notation is different. The formula is the same for both of them. The first thing we need to do is find the mean. Then once we've found the mean, we're going to find the deviations or the differences between our data values and our mean. Then we're going to find the absolute value of that difference, the distance from the mean. We're going to add all those up and divide by the total number of data values that we have to find the mean of those distances. So let's go through those steps. Justin did push-ups for a month. He recorded the number of push-ups he did each Monday. And there's the number of push-ups he did, 21, 24, 24, 27, 29. So the first thing we do is we decide, is that a population or a sample, just for our notation point of view, so we know how we're going to write it down. But really, we're doing the same thing, regardless of if it's a population or a sample. So in this case, because he recorded the number of push-ups he did each Monday and not every day, this is just sample data. He wasn't able to collect it for the whole month. So our sample data, when we talk about the mean of a sample, we're going to use X bar. And so that's when we do our notation, we'll just use that X bar. Well, first we need to find the mean of this data. In order for us to be able to find the average distance from the mean, we have to find the mean of the data. So I'm just going to take all my data values and add them together and divide by however many I have. In this case, 1, 2, 3, 4, 5. So I add this up. I have 5 plus 4 is 9, plus 7 is 16, plus 9 is 25. Carry your 2. 2, 4, 6, 8, 10, 12. So I have 125 when I add all that up. Divide it by 5, and 5 goes into 12 2 times with 2 left over. 5 goes into 25 5 times. So the average, or the mean of this data is 25. Let's see if that makes sense. Is that in the middle of our data? It is. It's there in the center, so it does make sense. Now, we're going to find the difference between each of those. To keep myself organized, I like to make a little chart of the data to help me to see exactly what I'm doing. So I'm just going to write down first all my little data values. I'm going to say 21, 24, 24, 27, and 29. Then in this next step, I'm going to find the difference between those data values and my mean. Just going to find out how far apart they are. So 21 minus that 25 is a negative 4. And 24 minus 25 is a negative 1. I'm just finding the difference between my data value and the mean. So 27 minus 25 is 2, and 29 minus 25 is 4. Now, if this truly is the mean, then when I add these numbers together, these differences, they should add up to be 0. Because when we find the mean, that's what we're doing, is so that when they share all out, they become 0. So let's see. Negative 4, negative 1 is negative 6, plus 2 is a negative 4, plus 4 is 0. So that tells me that is the mean. Now, I found those differences between the numbers, but really what I want is the distance from my data value to the mean. How far away is it? Well, remember that the way we find the distance is we take the absolute value of those numbers. So I'm going to take the absolute value of each of those. The absolute value of negative 4 is 4. The absolute value of negative 1 is 1. The absolute value of 2 is 2. And the absolute value of 4 is 4. Now that I found those distances, I'm going to find the average, or the mean distance from the mean. So I take each one of those and I'm going to add them together. So now the last step Notice that I've found this top part. I'm going to add all those together. That's what this says. Add all those together and divide by the number of values that I have. So I'm going to add all these values together and divide. Add these together. So all of these values, 4 plus 1 plus 1 plus 2 plus 4, and divide by the number in my sample, 1, 2, 3, 4, 5. So my sample size was 5. Add that up and divide, that's 5, 6, 7, 8, 9, 10, 11, 12, divided by 5. Well, 5 goes into 12 2 times with 2 left over. So 2.4 is that mean absolute deviation. That's the average distance that these values are from the mean. So that's just a measure of dispersion there. Math made simple at Simpson Math. Thanks for watching.